This is what we're looking at today. Today we're doing our quiz 11.1, goodness of fit test, and then we're going to do test of independence, and we're also going to do ANOVA. That kind of finishes out our material for the semester. Today you have due tonight 10.2, and then next Tuesday 11.1, and also Project Lab 10. There is a video on Lab 10 in Canvas, which I'll talk about in just a second. I'll show you guys that in a minute. And then next Thursday, you have 11.2 due, and then next Sunday, the Sunday before finals week, you have 11.3 due. So you have one Sunday, one coming up. And remember, again, the finals can be about 30% on chapters 10 and 11. So focus on those ones because the exam 4 is rolled into the final. And then also, there's going to be a couple of changes on the final. One is you have to upload a PDF, which actually was a change from last time, but still a handful of people did not do that. So there's a video on how to use Cam Scanner on Canvas, so you can kind of watch the video so you know how to use it, because you have to upload it as a PDF. There's zero chance I'm going to get all the finals graded on time if they're not all PDFs, and ideally one PDF. So if you go to Canvas, what you'll see in that first module up there that we have is you're going to see this right here. Maybe I should take a picture of it. It has other important information, like if anybody's interested in doing a pass not pass, or you have friends who wants to do an XW, this is information on the links to those forums and information on that. And then here's the video on how to use Cam Scanner. It's a free app, either in your iPhone or Android. It's available in both, and there's videos on how to use it in there. On the iPhone one's okay, it's not great. I'm working on getting Mr. K to write another one, Komazinski. I'm not sure how to pronounce his last name, but anyway, he's going to write me, make a new one for me. And then also there's a link to the video on how to do the Tech Lab 10. That's from last semester. So I explained it twice. One is short, like 5 minutes, the other one's a little bit longer, like 7 or 8 minutes, which is a little bit better of an explanation, I think. But they're back to back and they're tied in together. So there's the link on how to do those. Okay. Good. Oops. Uh-oh. My computer's upset. Okay, so let's go ahead and go over this a little bit before we get to the quiz. It's chi-squared, right? We're doing chi-squared things, and before we forget, go back. These are the things you need to know for the study guide. The final study guide is not a new study guide. It's select problems from your past study guides. So study guide exam 1, just do those problems, only those. Study guide exam 2, only do those problems. Study guide exam 3, only those. And study guide 4, exam 4, do all of them, because this is the exam 4. So exam 4 is part of the final. So take a picture of that. It'll be posted in Canvas under BoardWorks PDFs for today, for exam 2 and chapters 10 and 11. So it'll be there also, but take a picture of it now if you want it. And we're moving on in 5, 4, 3, 2, 1. Okay, so test of goodness of fit. We're doing the chi-squared goodness of fit test. It tests that an observed frequency meets an expected frequency distribution. So in other words, you have some, something you expect to get in certain percentages in each category, and what you observe matches what you expect. That's your H naught. H naught is always, always, always equals, so it's your observed equal your expecteds. H1 is that it's not the case. Your observed do not equal your expecteds. So that's your step 1. Always for chapter 11.1 and 11.2, you can just use those for all the 2 chi-squareds we're going to do. And then just a comment on the observed ones. The observed ones are the ones you're given. The frequencies that you're given are the observed. They are whole numbers. Right? So what you're given, that's the It's from a sample. Right? Sample, given. Those are your observed. The ones you expect to get, those are the ones you calculate. Those are the ones that they're expecting. It's either going to be, you know, a certain percentage for each one, so you have to figure out, well, 30% of 200 is this. You know, 18% of 200 is that. You either have to calculate it, or it's going to be a situation where it's all equally likely. So you just take whatever your n is and you just divide them equally amongst all the categories. So again, chi-squared is about categories. So think about chi-categories. I'll write that in there. Categories. That's the kind of the point of these ones. So you're all going to be about categories. Test for goodness of fit is this. Your chi-squared, your test stat, is going to equal to taking every single category and taking its observed value minus its expected value, squaring it, and dividing by the expected. Do that for every category, and then sum them, add them up. Your degrees of freedom is the number of categories minus 1. So you're going to use your chi-squared table for that. And the thing about that is you'll look and you'll see that as your degrees of freedom go up, like look here, it starts at 3.841. As the degrees of freedom go up, these numbers increase. Why would they increase? Usually they go down, right? They increase because we're not talking about n. The larger your n, the more accurate you are. Here, the more categories you have, the larger it's going to be because you're adding another category. Right here, I'm only adding degrees of freedom 1, I'm only adding 2 things together. Here, degrees of freedom 2, I'm adding 3 things together. Here, category, my degrees of freedom 3 means I have 4 categories, which means I'm adding 4 things together. So the numbers should go up as your number of categories increases, because here, remember, you're summing them, you're adding up more of them. If I have 5 categories, I'm going to add 5 things. I'll talk about that again later when we have more concrete numbers. I think that'll make it more sense to people. You can also use your calculator if you want to. I would do it for this quiz only because you have more than 4 and you have decimals. If I didn't have more than 4 and decimals, then I would just do it by hand. But if you have 5 or 6 or 7 or 8 or 9, then yeah, go and use your calculator. If you only have 3 or 4, just do it by hand. Okay, so again, we're going to try to calculate this. So one way you can do it is putting your observed into list 1, putting your expecteds into list 2. So then every time you see O here, you should write L1. Every time you see E up here, you should write L2. So it's your L1 minus L2 in parentheses, because you have to do that first, and then square it. So that's this, parentheses L1 minus L2, and parentheses, and then square it. And then divide by E, divide by L2, divide by L2. But that's not the end of it, because you still have to sum them, right? You have to add them up. So how do you sum them? You do stat calc on L3, because that's where you put all these guys, and you have to look at the sum of them, the sum of the x's, and that will tell you what they are all added up. That, I believe that's written in your, it might not be written in your notes actually. I tried to find it earlier, I couldn't. So you should write that down if you're going to use that. And actually you should write it down, because on the homework you might want to use that. I would say definitely the homework. I would say on the exam you probably don't need to, because I'm only going to give you like 3 or 4. And you're more likely to forget to do L3 here and screw yourself over completely, or than you are to, cause yourself more work. It's just as easy to do it by hand if you're talking about 3 or 4. Okay, so again, here's the steps, and I will leave that up there and let you guys go back into your groups so that you guys can, do you guys want to look through the one you did last class first? You did firearm deaths. Do you guys want to look at that first, yes or no? Because yes, okay, we'll go with that. All right, so here it is. I did it slowly, like on video, in slow motion, like regular motion, for my night class because they finished early enough to actually do it and get it done, and then we went over it. So you can look there if you want to see all the pieces with, as we're doing it. But here it is. Here's the answers. So this is the one you're supposed to complete before today. The observed and expected. The observed, we just gave this to you. The expected, you calculate those, right? Those are the percentages of whatever it was, 200, I think, something like that. And then here's your step one. H naught is O sub I equals E sub I. H1 is O sub I is not equal to E sub I. I'm going to move through this pretty quickly, so take a picture if you should just be checking your answers, honestly. So take a picture if you really want. And then we found our critical value. We looked it up. Degrees of freedom is 3 categories, so 3 minus 1. So that's 2. Degrees of freedom 2. Alpha is 0.10, so our critical value was 4.605. And then we computed the test value of this test stat. I just did that by hand, I think, because it was really easy to do. There's only 3 of them. And you end up getting 7.23 as your test stat. And then move it on. We rejected the null hypothesis because here's my critical value here, shade this way. 7.23 is way over here. It's in the rejection region, so we're going to reject H naught. So there is enough evidence, and you could just type in here enough evidence to reject the claim that the proportion is as stated. That would have been fine. Okay, so now we will go back. Go ahead and work on your problem, but I will go back and put up the summary. So I'll open up the breakout rooms again, and I'll put up the summary up here in case you need it, which is right there. There we go. Good. Yes. Uh-huh. Almost always it should, right. Right, so almost always H naught is going to be your claim. And almost always it's going to be that the observed equal the expected in some way. What you observe, it should equal what you expect in some manner. Are the ones that you see, right? So these are the ones that are given. So those are right in here. So just write those in first. So 1, 2, 3, 4, 5, 6, write those in. And then the expected is the ones you have to calculate. We have 200 roles, 6 categories, so I'm just going to divide by 6. So 33.33 each. And you can just do 3 sig figs, so that's fine, 33.3, that's all good. And then my alpha, so then alpha is 0.05. Change that from your quiz if you printed it off, it should be 0.05 because we don't really have 0.025. So H naught, O sub I equals E sub I, that's my claim. H1 is O sub I equals E sub I. So your homework may give you H1 as a claim, possibly, for these chi-squareds, but on the exam, on the final, I'm only going to give H naught as a claim. So for me, the null hypothesis will always be the claim on the exam for 11.1 and 11.2 for chi-squareds. For chapter 10, then H1 is always going to be the claim. So 10.1, H1 will be the claim, that it is a line. And then for 11.1 and 11.2, the claim will be H naught. And actually for all of chapter 11, 11.3 as well. On the exam, the claim will be H naught. So those are kind of fixed. So again, for chapter 10, H1 will always be my claim on the exam, and for chapters 11, that's 11.1, 11.2, 11.3, H naught will be the claim on the exam. But your homework may be different. Your homework will vary a little bit. Okay. You guys can't see that. All right, so my critical value, let's see, my degrees of freedom is number of categories minus 1, so I have 6 categories, so it's going to be 5. I'm going to pull up my handy dandy table. Well, maybe not. I think I left that behind. And alpha is 0.05, degrees of freedom 5. So here's my alpha 0.05, degrees of freedom 5 is this one right here, so 11.07 right there. That's it right there. So that's my my critical value, and again, it's just this up, straight up, very steep up, and then swoop off, right? So just up and swoop off. That's what we're doing here. Just up and swoop off. That's this chi-squared curve. And remember, it starts at 0, and it only goes up, because the least you can have when you add up a bunch of stuff that's positive. These are always positive, right? Because I'm taking a difference, but then we're squaring it. And once you square it, if you square anything, it has to become positive. Anything squared is positive, because a negative times a negative is a positive, positive times a positive is a positive. So it's always going to be positive. We're going to divide by the expected value. You can never expect negative people, so that's always positive as well. So you're going to add up a bunch of things that are always positive. You're always going to get something positive. And so all you can do is become larger and larger than 0. The more things you add, the bigger, the bigger number you're going to get, which is why the degrees of freedom is based upon categories, not your n, because the more categories I have, the more things I add. And we can talk about that more a little bit later. I'll tell you guys that now, and we'll go into it more later. So here's each one. Someone asked, do I have to write them out? Yes. So here's the thing. On the exam, you have to write this out. 30 minus 33.3 squared divided by 33.3. You're only going to have 3 or 4 of them. 4 at the most. You can totally write them out. They're not hard. The other one, 27 minus 33.3 squared divided by 33.3. So if you haven't written them out, write them out now. Write them in there. And if you add them all up, you will get 9.77. So pop that into your picture. Don't forget to pop that in. A couple of you guys did not put this into your picture. You only had the critical value. And you lost a point on every hypothesis test on exam 3. Because when you rejected H naught, I didn't know why. You didn't show why. Right? You either have to say, because blah, blah, blah is greater than blah, 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 or you have to show it on your picture and put it in there. A couple of you lost some points because you didn't shade. Right, you have lost a half point for everyone you didn't shade, because I don't know which one's the critical value and which one's the test stat. Now, if you labeled them, then that's fine. But if you didn't label them, you got to shade. Right, you shade the critical value. So we have the guilty region. Okay, do not reject H naught, because it's in the not guilty region. So there's not enough evidence to reject the claim that the proportions are as stated. That's all you have to put. I'm totally fine with just that. No worries, all kinds of good. Yes.
For this problem, isn't H1 the claim?
I am okay with you guys probably. Let's see. Oh yeah, they're claiming they're not equally likely. So here this is, and your homework may have it like that. But yeah, for the exam, I don't care. I'm just going to just always pick H naught for it. Does that make sense? So on your homework, then totally. If you put that, then that's totally great. If you put, if you had put support, right? If you had put this instead, or not enough evidence to support claim that the proportions are different, proportions differ,
right,
then that would be okay too. They're both totally fine. I'm just trying to keep things super simple for people, and not make it too complicated. So I'm totally okay if you just want to stick with always doing this, reject claim the proportions are as stated. I'm okay with that. So if you want to do that for all the chi-squareds, for 11.1 and 11.2. But this is better. The bottom one's better. Totally not necessary for me. You will need it for the homework. So you got to pay attention to that for the homework. The homework's going to make you kind of read through and see that problem and say, oh, they're claiming that the proportions are not the same, that they differ. And so you have to realize that that's, right, it says outcomes not equally likely. So then you say, okay, this is the one where this is where they are equally likely, so then H1 would be where they're not. So totally, I'll put that in there. Portions are not equally likely. Not equally likely. Okay, great. So why don't you guys go ahead and do your shopping bag problem now. I will give you guys, let's take 10 minutes to do that, and then we'll take a 10-minute break. But before you go, I want you guys to work on the shopping bag problem together for just a couple of minutes, us together. Let's get a reader. Jay, you're awake, so why don't you go ahead and read it? Just read the shopping. Just do the text. Start from here, actually. Just start from here, from the types of shopping bags used. That's okay.
Oh, the types of shopping bags used in a magazine survey, 60% of the respondents said that they use reusable shopping bags, 32% asked for plastic, and 8% requested paper. A random sample of 300 shoppers revealed that 28 asked for paper, 120 requested plastic, and the remaining shoppers had reusable bags. At alpha 0.01, does this differ from the results of the survey?
Great. So, what are our categories? Everyone make your little observed and expected and write out your 3 categories right now. Right now, write out the 3 categories that you have. Find them, write them out. You have 15 seconds to do that. Do it. Wake up, everyone. Find the categories. Write them out. Okay, so you guys should have found the 3 categories and written them down. You should have reusable, plastic, and paper. That's what I've got. Right? Reusable, plastic, paper. Write those in. And then put in your observed. Right, so we have and find a random sample, because the observed, again, are always what you're given. We give you the observed. Here they are. Here you go. So write those in. Write them in now. Don't say I'm going to do it later. Write them in now. So we need to talk about this, and it's going to help you save you potentially hours on your homework if you do it now. Have your 3 categories: reusable, plastic, paper. Write in your observed. Remember, it's always going to be from your sample, what you're given. And we have 300 shoppers, right? So 300 shoppers, 28 paper, 120 plastics. That means the rest of them, 300 minus 28 minus 120, that was the rest of them. Okay, so quick question. Did you guys get reusable? Did you get 28? 28 here. And then let's see, 120 there. And then the rest of them, 152 there. Did anybody get that?
Yeah.
The thing about it is that they're tricky. They are not in the same order. Your homework is going to do that to you too. It's going to kind of try to screw you a little bit. So you got to pay attention, because it will mess you up on the homework like you would not believe. 28 paper, these are not in the same order. It gave you to you as reusable plastic paper, boom, boom, boom. And then down below, it gave you to you in a different order. Paper, then plastic, and then it didn't even say reusable. So paper, 28, the last one first, and then 120, plastic next. And then you got to calculate the first one. So pay attention to that because your homework will totally do that to you on a couple problems. And I had a student last semester who literally spent over 2 hours. She must have done that problem 10 different times with different data and couldn't get the right answer because they messed up the order on her, and they will do that to you. All right, so I'm going to open up your rooms. Go ahead and I'll give you guys, you now have 6 more minutes to finish this up and then take a break until 6:05. Come back at 6:05.